Alright, here is a tricky SAT question that has no correct answer. In the figure above, the radius of circle A is 1/3 the radius of circle B. Starting from the position shown in the figure, circle A rolls around circle B. At the end of how many revolutions of circle A will the center of circle first reach its starting point? So there are no correct answers. None of these answers is correct. Why? Well, let me show you. First, it's good to know what is the circumference of each circle. So for the smaller circle, it's 2 pi r. Let's assume we have some r here. It's for the smaller, for circle A. And for the bigger one, circle D, it's 2 times pi times 3r. Here we have 3r. So it's 6 pi r. Okay. Now you may think that the answer is B, so 3. Because if I took a rope and put the rope around the smaller circle and the next rope around the bigger circle, I could see that the shorter rope that demonstrates the circumference of smaller circle is exactly three times shorter than the rope that demonstrates the circumference of bigger circle. So here is 2 times pi times r, and here would be 6 pi r, 3 times. But here's the trick. What matters is the shape of the path along which you travel, because as you turn this small circle around the bigger one without any slipping, you travel a longer distance than you would if you were rolling it over a straight line. Why? Because if there is no slipping, the center, here's the center of this small circle must cover the same distance as any point. Well, not exactly as any point, but because there is no slipping, the distance that the small circle center travels around the larger circle is equal to the total arc length that has rolled on the small circle itself. So in this case, the radius of the path that we must consider is 4r, because it's 3r from circle B and r from circle A. And then the circumference of this bigger circle, of the biggest circle that we have here, is 8 pi r, and that gives us 4 total revolutions. So 4 revolutions is the answer.